All right, last test of the year. Remember, you get the formula sheet, and on that formula sheet, they'll be separated out arithmetic and geometric. So make sure you check the correct section on the list. So here we have a sequence that has a name, P, that's all that is, so that really doesn't mean anything, it's just the name. And so to find the first four terms, obviously we'd plug in a 1, then a 2, then a 3, then a 4, unless of course you can figure out the pattern, and then you would need to plug that number in each time. I would come up with a few numbers before you come up with the pattern though. Don't just assume you know what it is with the first two. So if we plug in a 1, we get 9, 2 would be 4 plus 7, 3 would be 6 plus 7. It does look like we're adding 2, so then 15. So then to find P sub 21, you just put the 21 in there. So we would have 2 times 21 plus 7, and that of course is 49. The quiz has maybe 13 or 14 questions on it. There is one question like this one and one question like this one. Now for this problem, yours is correct, mine is incorrect. A sub n is negative 52. And so we're going to work backwards here. So we know, according to the formula, right, a sub n, so negative 52, is equal to the d, negative 5, times n minus 1 plus a sub 1. And then we'll just go ahead and figure this out. So this is 8, so we get negative 60 equals negative 5n, and then n is 12. Oh, that's all we had to find, was n. There will be one question like this one as well. Actually, there's one question like all this. So how about that? All right, so for number 4, we have an arithmetic sequence. We're looking for the sum of the first 12. All right. In order to find the sum of the first 12, we need the 12th term. So I'm going to find the difference, because I know it's arithmetic because they told me that, which is nice. So I'm going to find the difference. So the difference is 90. Oh, we need the first term, sorry. We need the first term. So 90 minus 27, and then if we subtract their term numbers, 12 minus 3, divide this out, this is 63 over 9, so our difference is 7. Now, I know a sub 3, and so I'm not beyond just doing this, right? Subtract 7, subtract 7. So a sub 1 is 13. Remember, just basic arithmetic can probably get you through a lot of this. You just sometimes, if you have to add 54 times, then do it. Like if you can't use the formula or figure it out. So S sub 12 is going to equal to 12, because that's our term number. First plus last divided by 2, and this is 618. There's a problem like number 5 on there as well. So there's one problem like this, one problem like this, one problem like 6, one problem like 7. So there you go. As far as I can see, that's what we got. So we've got a marathon is 26.2 miles. We're going to run 3 miles the first day and increase by 0.8 each day after. So how long will it be until they can run the full marathon, which of course is 26.2 miles. So we're looking for n again, number of days. So we know that 26.2 is the goal, or a sub n, and we know that each day goes up by 0.8. We don't know how long it'll take, and the first day was 3. So we'll solve this, and then we get 26.2 is equal to 0.8n plus 2.2. And then we'll subtract it over here. So 24 is equal to 0.8n, and then we get n equals 30. So 30 days. So those two problems do feel a lot alike. Obviously, one story problem, one not. So now we're going to switch to geometric. So again, pay attention to the formulas you use. So we're looking for a sub 8, and we know that that is a sub 1, and then the ratio to the n minus 1 term, or n minus 1 power, sorry. Put that into the calculator, 21.5. Sum of the first 12. Better figure out if it's arithmetic or geometric. It doesn't seem like we're adding or subtracting consistently, so let's see if it's got a ratio in there. 6 over 8 is 3/4. 4.5 over 6, throw that in the calculator, that's 0.75, so we're good. So we definitely have a geometric, so we know that the sum of the first 12 is equal to the first term, 1 minus r, which you can call 0.75 if you want. And that, of course, is to the nth term, nth power. I don't know why I keep saying that. And the bottom is 1 minus r. Put that in the calculator. It doesn't go back to a fraction for whatever reason. I put in with the fraction key even, and I couldn't get it back to a fraction. So we'll just call this 30.986. Number 8 is not even on your paper because number 8 is not on the test. So this is the new number 8. Calculator, if you want to use that key on your calculator, or if you need to do the sum, remember your first term is really a sub 2 and your last term is really a sub 6. So make sure you pay attention to using the correct term numbers. With the calculator, though, we get 1092.3 repeating. And yes, there will be one problem like this on the quiz. Writing in sigma notation. I feel like this is a more fair question because if you have a calculator without the key, it doesn't affect that. So there will be one question like this. Recursive and explicit, you know that's going to be on there. So there's ones like all of these, and then there's 2 like these down here. Number 13 is kind of a weird problem. We'll talk about it when I get there. But so writing in sigma notation. First of all, let's determine what we have, arithmetic or geometric. It does look like we add 3, so we have a difference of 3. So we know that a sub n is equal to 3 times n minus 1 plus 6. So 3n minus 3 plus 6. So that is 3n plus 3. So when you write the sigma, it looks like we're going from n equals 1 to infinity. Right? There's no end, and then this is 3n plus 3. Okay. So here we have the recursive. We're trying to find the explicit. So whatever helps you, I'm going to write this out. That helps me to actually write it out. So my first term is 2. And my next terms after that, I'm just going to multiply by -3. Oops, that's not multiplying by -3. If I multiply by -3, I get -6, and then +18, and then so on and so on. I know my ratio is -3. And so the explicit formula is the a sub n formula. So the first term is 2. The ratio is -3. I'm going to raise this to the n minus 1 power. Done. All right, so recursive and explicit formula here. I'm going to do the recursive one first, just because, I don't know, I got to do something first. So let's see, we have -7 minus -18. So 11. 4 minus -7, 11. So our difference is 11. So it's arithmetic with a difference of 11. So a sub 1 is -18, and then a sub n is the term before it plus 11. So this is the recursive. The explicit uses the formula on the paper. A sub n, which is what I'm looking for, is the difference times n minus 1 plus the first term. And then you just simplify this till you get it to say a sub n is 11n minus 29. Now there is no problem like number 13. I was going to do it, and then I kind of thought this was too guess and checky, and it wasn't too, kind of uncertain. But let me go through this with you. You can skip this part if you want. So we know that our total, when you add them all up, we get that much money. And we know that there is a difference of 100 from prize to prize. So we know in the sum formula, 5510 is equal to, right, 10 times a number plus a number divided by 2. We don't have any idea what either of those numbers are. But then the 10 divided by 2 is a 5. Then divide both sides by 5. We get 1102 is equal to these two numbers added together. Now you kind of understand that obviously with a $100 difference, that the numbers are like 300, 400, 601, 701. So you can almost kind of work backwards from there, which is why I don't like this problem. It's not really, like I said, it's kind of guess and check. And so I just went with the assumption that the first prize wouldn't be very much. And since this ends in 2, I know my numbers have to end in 1. So I went with 101, and then I just did 1,001. I just worked backwards. Those two numbers work. I don't know if there's more numbers that work, because once I got some that worked, I stopped. So the prizes would be $101 and $1,001. There might be more than one answer there, but this is not a very good problem. You won't see one like that on the quiz. But you will see these. So you're looking to find your ratio. This is the S sub infinity formula on the geometric portion. So for number 14, 1 to 5, 5 to 25, looks like we're multiplying by 5. This is divergent because your ratio is so large, meaning it approaches infinity, and so there's no sum. Nice and easy. On number 15, looks like we have 1/8 divided by negative 1/4. Looks like we're multiplying by negative 1/2. Yep. So the sum of the infinite amount of terms, simple formula, is the first term, and then the denominator is 1 minus the ratio. Throw that in the calculator. Negative 1/2, negative 1/4 divided by 3.5, or sorry, 3/2, if I can talk, and then this will give you negative 1/6. So that is the whole quiz. Like I said, it is about the same length as this review sheet if you take off number 13. So what does that make this? Maybe 13 questions? 12 questions? Something like that. It's not very long.